Good morning, friends. Today I am covering the difference between mean, median, mode, standard deviation, and variance. This question generally comes in board exams and even when you pursue your graduation or post graduation. These five things are part of the curriculum there also. So let's start. Suppose 10 numbers are 12, 7, 10, 4, 12, 19, 8, 9, 7, 12. I took here 10 numbers just for giving you the example. You can take 20, 30 or whatever number you like. So I just took 10 random numbers here which is written as 12, 7, 10, 4, 12, 19, 8, 9, 7, 12. To make calculations easier, especially for the median and the mode, first arrange them in ascending order. 4, 7, 7, 8, 9, 10, 12, 12, 19. So I arrange the numbers in ascending order for median. Total number of values here are n equal to 10 because I took 10 numbers. So in order to find the mean is basically sum of all numbers divided by n. So the sum of all numbers given here are 100 and the total number are 10. So mean is 100 divided by 10 is equal to 10. Median. The median is the middle value of an ordered data set. Since we have an even number of observations n equal to 10, the median is the average of the two central numbers, fifth and the sixth terms. So here n is equal to 10, then median is the average of two middle terms. If I exclude first four terms and the last four terms, then two middle terms are fifth and sixth. So to find the median, the data should be arranged in ascending order. So the two middle terms in our case are 9 and 10. So median is equal to 9 plus 10 divided by 2. In case the numbers are odd, I took 10 numbers here. In case I took 11, then median should be sixth term. So when the numbers are even, then median is exclude the first four or five terms depending on the number of terms and take the two middle terms and divide by 2, and if the numbers are odd then median is the middle term. I hope you understand till here. So median in our case is 9.5. Mode. The mode is the value that appears most frequently in the dataset. In our case it is 12. So 12 appear three times here. So mode is the value which appears most frequent in the dataset. To find the variance, let's calculate variance. We first need to find sum of squared deviations from the mean. So value here are 10 numbers. The numbers which I arranged in ascending order, I wrote down here. And deviation from mean in our case is 10. So this number is deviated from mean by -6. So whatever the numbers I have, I'm just subtracting the mean value from all the numbers. And after that, I have to do the square of the deviation. So value is 4, 7, 7, 8, 9, 10, 12, 12, 12, 19. Then 4 minus 12 is -6, 7 minus 10 is -3, 7 minus 10 is -3, 8 minus 10 is equal to -2 and so on. Then square of deviation, whatever the deviation I get here, I did the square. -6 square is 36, -3 square is 9, -3 square is 9, -2 square is 4, -1 square is 1 and so on. And I find the sum of the square deviation which is 152. So first take all the numbers, then number minus the mean value and then square the deviation and find the sum. Depending on whether these 10 numbers represent a complete population or just a sample of a larger group, the formula differs slightly. Both methods are provided below. So there are two methods to calculate the variance. First is if this is a sample, which is the most common method, then sample variance is divide the number sum by n minus 1. So sum in our case is 152. Divide this by n minus 1, and in our case is 10. So 152 divided by 10 minus 1 is 152 divided by 9, which is 16.89 approx. This is if I took a sample. If I took an entire population, then sample variance is divide the sum by n. Sum, which is 152, and n is number of terms. In our case is 10. So 152 divided by it is 10. 152 divided by 10 is equal to 15.2, and it is a approx value. I will let you know what is the difference between a sample and a population in few minutes. So these are the two formulas. Same standard deviation is basically square root of sample variance or population variance or population variance. So if this is a sample, standard deviation is what is the value of variance in our case of a sample is 16.89. So square root of 16.89, which is equal to approximately equal to 4.11. And if this is an entire population, then standard deviation is equal to square root of 15.2, which is the variance value in case of a population. So square root of 15.2 is approximately 3.90. So for standard deviation, just square root the value of variance, whether it's for a sample or for a population. Let's understand the difference between a sample and a population. Population is the entire collection of things or people you care about, every single people living in a country, for example. For sample, a smaller piece or subset of that entire population, let's say 100,000 people surveyed from that country. So if I am considering the population, then I have to consider the entire population. Let's say the entire population of a country is 1 lakh, then I have to consider the 1 lakh people. And if I am considering a sample only, then I have to consider a smaller piece or subset of that entire population. Let's say 1,000 people surveyed from that country. From 1 lakh people, surveyed people are 1,000. So this is a basic difference between a sample and a population. Population is the entire and sample is just a part of that entire. The main difference in variance. Variance measures how spread out your data points are from the average, which is mean. So for population variance, you use this when you have measured every single member of the group. Since you have 100% of the data, your average is perfectly accurate and you divide by the total number of terms, which is n. So for population, we have to consider the entire data, which is 100%, and we have to divide by n, which is here. Entire population is divide the sum by n, and if it is a sample, then divide the sum by n minus 1, which is written here. For sample, you have to use this when you only have a subset of the group, because a small sample is highly likely to miss extreme high or low values, outliers. Generally, a sample naturally tends to look less spread out than the real population actually is. So in order to fix this estimation and be mathematically safe, we have to divide this by n minus 1, the sample size minus 1. sample size in our case is 10 instead of just n. So we have to divide by 9 instead of 10. Dividing by a slightly smaller number makes the sample variance a little bit larger, which gives a more accurate, unbiased estimate of what the real population spread looks like. So this is the basic difference when you find a variance for a sample or a population. So in this video I covered the basic difference between mean, median, mode, variance and standard deviation. I hope you understand what I just explained. If you have not subscribed to my channel, please subscribe my channel for more videos in the upcoming days. Thank you.